This is our third video on distinguishing unknown compounds, and in this one we're going to focus on how to use precipitation reactions to determine what the substance is. Now, in order to determine the unknown compound, you've first of all looked at colour and you've already checked solubility. So now we're up to the third step. We're trying to use a precipitation reaction in order to tell two compounds or three compounds apart. In order to do this, you will have to work out what soluble substance you can add to precipitate another compound. Now let's try another example. This time we're looking at chromium 3 nitrate and chromium 3 chloride. So looking at the picture, you can see that when we look at the colour of the compounds, they are both deep green. So the second step is to check the solubility. So we add water to dissolve. Remember, you're trying to give a set of instructions. And we check our solubility tables and we find that both chromium nitrate and chromium chloride are soluble. So now we're at the precipitation reaction. So we're going to have to go to our data sheet and check out the differences between chlorides and nitrates. We can't distinguish on the chromium because they're both deep green. So let's check out the solubility tables. If I look at most chlorides, I can see that most chlorides are soluble in water. There is an exception though, and that exception is silver chloride. If I look at most all nitrates are soluble in water. So we've got to check out the differences between the two, and the major difference is that silver chloride is insoluble, but silver nitrate is soluble. So our goal is to make silver chloride. So we have to think, what can we add to make silver chloride? Well, we've already got chromium chloride. So there's our chlorides. What we now need to think about is what reagent we're going to add to make silver chloride. Now, obviously it has to have silver in it because we want to make silver chloride. So we have to think, when is silver soluble? Because to do a precipitate reaction, you need two soluble substances. And you can see that silver is soluble as a nitrate. So I'm going to add silver nitrate. Using chop kapow, you can see that I would now make silver chloride, and our other product would be chromium nitrate. This obviously needs a balance, so I'm going to have to put a 3 here and a 3 here. Now, if I add silver nitrate to chromium nitrate, you can see by doing a chop kapow that you will actually get no reaction. So we have distinguished between the two solutions. So we looked at the compounds, they were both deep green. We looked at the solubility, we added water to dissolve them and they were both deep green. And now we're added silver nitrate solution, and you can see that with chromium nitrate we've got no observable change, and with chromium chloride we got a white precipitate. And the overall equation was chromium chloride add silver nitrate gave us silver chloride plus chromium nitrate. Don't forget to balance. Now let's try a third example. This time we've been asked to distinguish between copper sulfate and copper nitrate. So the first thing that I'm going to do is I'm going to look at the colour of the compounds, and I can see that both of them are blue. So copper sulfate is blue and copper nitrate is blue. Now our second step, remember, is to go to the data sheet and check out the solubility of these compounds. Now, because we're writing a set of instructions for a fellow U10, we're going to tell them that they need to add water to dissolve the blue compounds. And using our data sheet, we see that copper sulfate is soluble and copper nitrate is also soluble. So we're going to have to go to step 3. Now step 3 is a precipitate reaction. Remember, to do a precipitate reaction you need 2 solutions. So we are going to need to find a solution that will precipitate either the copper sulfate or the copper nitrate. Now we can't precipitate on the copper ions because they've both got them, but we can look at nitrates and sulfates. To do that, we're going to go to the solubility table. Now we've gone to the solubility tables. So we look at copper sulfate and we can see that most sulfates are soluble, but there are some exceptions. We look at nitrates and all nitrates are soluble. So the ultimate goal now is going to be to make a precipitate. And to do that, we could make a strontium precipitate, a barium precipitate, or a lead precipitate. And this is the goal. I want to make, for example, a barium precipitate. So I'm going to say I want to make barium sulfate. Now if I want to make barium sulfate, when I add barium something to both test tubes, my copper sulfate is going to provide the sulfate ions to make the barium sulfate. I obviously need a barium ion to make the barium sulfate, but the barium ion has to come with something. So it has to be a soluble barium ion. Now I always like to use a nitrate because every single nitrate in the entire wide world is soluble. So if I add barium nitrate to my 2 test tubes, I will make a barium sulfate, which will be a precipitate, plus copper nitrate. So this one here will give me a precipitate. But if I add barium nitrate to copper nitrate solution and do chop chop kapow, you will find there would be no reaction. So no reaction. And if there's no reaction in one test tube, but there is a reaction in another test tube, we can now tell them apart. So now we've actually distinguished them. We've looked at the colour, they were both blue, didn't help us. We dissolved both in water because they were both soluble, and then we added barium nitrate solution. So when we had copper nitrate solution, this gave us no observable change because there was no reaction. And when we added it to the copper sulfate solution, we got a white precipitate of barium sulfate. So the reaction was copper sulfate and barium nitrate gave us barium sulfate plus copper nitrate solution, and hence we have distinguished them. Now let's try one last example. This time we're going to try and distinguish between nickel sulfate and nickel chloride. Looking at the compounds, you can see that, look at the colour, you can see that both are green. So that's not very helpful to us. Now, step number 2. Add water to dissolve green compounds. So when I check my solubility tables, I find that both nickel sulfate and nickel chloride are both soluble. Now, our third step is to do a precipitate reaction. So we're going to have to look at the solubility tables. So, looking at the chlorides and the sulfates. Now, when you look at the chlorides and the sulfates, you find that silver chloride here is insoluble. So now we've got to check it against the sulfates. Unfortunately, silver sulfate is slightly soluble, so you'll probably show a precipitate. So that's no good to us, so we can't use silver. Now, what else could we use? If we look at this one, you can see that lead chloride here is slightly soluble, and lead sulfate here is insoluble. Now, because they're slightly soluble, you'll probably get a precipitate, so we don't want to use those. So we either want to make strontium sulfate or barium sulfate. I always like to make barium sulfate. So if I wanted to make barium sulfate from my nickel sulfate, I've already got nickel sulfate. So the sulfate's already provided. I want to make barium sulfate. So if I want to make barium sulfate, I need a barium ion. So I'm going to add barium something. So the best choice in this case is probably barium nitrate, because we know that every single nitrate in the whole wide world is soluble. And that will mean that we will make barium sulfate and a solution of nickel nitrate. Now, if we added our barium nitrate to our nickel chloride solution, we would find, doing chop chop kapow, it would be no reaction. So now we've actually distinguished between nickel sulfate and nickel chloride. We looked at the colour, both green, that wasn't helpful. They were both soluble in water, so also not helpful. But now, if you added barium nitrate solution, what we found was our nickel sulfate solution gave us a white precipitate, and we can write a reaction for that. So nickel sulfate and barium nitrate gave us nickel nitrate solution and our precipitate of barium sulfate. Then when we added it to the nickel chloride solution, we got no observable change. Now I would like you to try one yourself. Go to the OneNote and try example 6.